Earth appears calm and stable today, wrapped in a thick blue atmosphere that supports oceans, weather, and life itself. But this stability is deceptive. In the long history of our planet, there was a moment when Earth came dangerously close to losing the very air that makes life possible. This is not speculation or science fiction. It is a real event, supported by geological records, space physics, and planetary science. To understand how close Earth came to catastrophe, we must first understand how fragile an atmosphere truly is. An atmosphere is not permanent. It is constantly being pulled away by gravity, heated by radiation, and stripped by stellar winds. In the universe, planets without atmospheres are far more common than planets with them. An atmosphere survives only when three conditions are met: sufficient gravity to hold gases, a continuous source to replenish those gases, and protection from the violent energy of the host star. Earth meets all three requirements, but only barely, and not always consistently. 4 billion years ago, the sun was very different from what we see today. It was younger, faster spinning, and far more aggressive. Young stars release intense ultraviolet radiation and frequent massive eruptions known as coronal mass ejections. These events send billions of tons of charged particles racing through space at extreme speeds. When these particles collide with a planet's atmosphere, they transfer energy to atmospheric atoms and molecules. If enough energy is transferred, those particles escape into space forever. Over time, this process can completely strip a planet of its atmosphere. This exact fate happened to Mars. Mars once had rivers, lakes, rainfall, and a thick atmosphere. Geological features still visible today confirm this. However, Mars lost its global magnetic field early in its history. Without magnetic protection, the solar wind directly struck the Martian atmosphere. NASA's MAVEN mission has measured this loss in real time, confirming that Mars continues to lose atmospheric particles even today. Earth and Mars began their histories in similar ways. Both formed from the same protoplanetary disk. Both had early atmospheres. Both were exposed to the same violent young sun. Yet one world survived, and the other became a frozen desert. The difference lies deep beneath Earth's surface. At Earth's center is a solid inner core, composed mostly of iron and nickel. Surrounding it is a thick layer of liquid iron, constantly moving due to heat escaping from the core and the planet's rotation. This movement generates electrical currents. Those currents generate magnetism. This process creates Earth's magnetic field, which extends far into space, forming a vast protective bubble called the magnetosphere. The magnetosphere deflects most solar wind particles, forcing them to flow around Earth rather than directly impacting the atmosphere. Without this magnetic shield, Earth's atmosphere would be exposed in the same way Mars's atmosphere was. However, Earth's magnetic field is not constant. It fluctuates in strength and structure over time. Geological evidence preserved in volcanic rocks shows that Earth's magnetic field has weakened, shifted, and even reversed many times in the past. One of the most dangerous moments occurred approximately 42,000 years ago. This event is known as the Laschamp excursion. During this period, Earth's magnetic field weakened to less than 10% of its normal strength. The magnetic poles wandered far from their usual positions. In some regions, the magnetic field nearly vanished entirely. As the field weakened, Earth's magnetosphere shrank. Solar wind particles penetrated deeper into the atmosphere. Radiation levels at the surface increased dramatically. Auroras, normally confined to polar regions, appeared across much of the planet, even near the equator. Cosmic rays reached the ground at levels far higher than normal. Ice cores drilled from Greenland and Antarctica preserve evidence of this event. Scientists have identified spikes in radioactive isotopes such as beryllium-10 and carbon-14, which form when cosmic rays interact with the atmosphere. These spikes confirm that Earth was exposed to intense radiation during this period. Ozone levels likely dropped significantly, allowing harmful ultraviolet radiation from the sun to reach the surface. This would have stressed ecosystems, damaged DNA, and disrupted climate patterns. Some researchers believe this period coincided with major environmental changes, shifts in human behavior, and the decline of Neanderthal populations. While life survived, it did so under extreme stress. Computer simulations show that if the magnetic field collapse had lasted longer, Earth could have entered a slow but irreversible process of atmospheric loss. Hydrogen would have escaped first, breaking apart water molecules. Over time, oceans would have gradually diminished. Oxygen would react with surface rocks. The planet would dry cool and lose its protective air. Earth narrowly avoided this fate, Because the magnetic field recovered, the molten iron inside Earth continued to move. The geodynamo stabilized. The magnetic field strengthened again before atmospheric loss reached a critical tipping point. This was not guaranteed. It was not inevitable. It was a matter of timing. The story of Earth's survival is not a story of permanence. It is a story of balance. Today, Earth's magnetic field is weakening again. Measurements taken since the 1800s show a decline of roughly 9%. The magnetic North Pole is moving rapidly across the Arctic. A region known as the South Atlantic Anomaly has expanded, where satellites experience higher radiation exposure. These changes do not mean catastrophe is imminent. Magnetic field fluctuations are normal on geological timescales. Earth has undergone hundreds of magnetic reversals, and life survived all of them. But modern civilization is far more vulnerable than ancient life. Satellites, power grids, navigation systems, and communication networks depend on a stable magnetic environment. A major weakening or collapse would not end life, but it could disrupt technology on a global scale. Earth remains habitable today because multiple rare factors continue to work together. A molten core that has not yet cooled, active plate tectonics that recycle gases, a large moon that stabilizes Earth's rotation, and a position in the solar system that avoids extreme heat or cold. Remove any one of these factors, and Earth would resemble Mars or Venus. The atmosphere above you exists because deep beneath your feet, iron is still flowing. One day, billions of years from now, Earth's core will cool, the magnetic field will fade, the sun will continue to strip away the atmosphere, oceans will disappear, the sky will vanish. But today, the shield remains. This fragile protection has preserved life through cosmic violence, solar storms, and near collapse. Earth did not survive because the universe is gentle. It survived because the balance held just long enough. This story, written in magnetism, radiation, and stone, reminds us that the sky is not permanent. It is a temporary gift, a miracle of physics, a narrow escape. A story told across the vast scale of time and space. A story shared with you by Infinite Cosmos.